Hi everybody, my name is Jordan Richardson. This is CSE 546, Introduction to Machine Learning, Assignment 2. Um, to start off, this is the assignment we had. So basically we were using these different models with these different parameters. We wanted to apply five-fold cross-validation, find the optimal parameters, compare the accuracy attained during training to those tests, define overfitting, underfitting, look at some of the misclassified examples, and select the best algorithm based on these. So I'll start with this just to show that my code runs. So basically, we load the data. We were told to drop this row by the column by the instructor. We separate into target and feature. I decided to measure the time this time around. Use scalar to standardize all the features. We set a range of k values. This stores the cross-validation scores. And then we go into a for loop that does this for all of those k values. It's then going to find the optimal k, calculate the time taking, and plot it. So this is what comes back for k1 to 20. And so it identified the best k to be 5, which is right here. And if we close this, it'll tell you it took 4.7 seconds. And the testing accuracy was 90.27%, while the k cross validation was 90.61. We had 112 emails that were misclassified, and here's 5 of them. So I'll show you that these run as well, but these are basically set up in the same manner. I was actually able to carry over quite a bit of code from each of these, as you'll see from my output in the graph. And this was identified as 1. Yeah, 10 to the 0 is the best. The test for that was 91.92 or 93.19 for the cross-validation accuracy. 93 emails were misclassified in comparison to the first one. And this is my presentation for homework 2, classification algorithms, again by Jordan Richardson. So I created an agenda. So first we're going to do an introduction to what the assignment was, and then we'll go through each of the different algorithms. For this project, we were to build and analyze classification algorithms based on KNN and linear models. The classification methods provided to us were KNN binary classifier, logistic regression classifier, and linear support vector machines classifier. The features and target variable were indicated clearly. We had to attempt to find the best parameters for our models to obtain the most correct classifications. We also needed to identify cases of underfitting and overfitting, along with comparing the accuracy and explainability of each method. My initial thoughts for the assignment. I found this assignment easier to code, but I'm hoping to get some experience with image classification or generation, or really just any other type of, sensual data sets, visual, sound, or anything else. But I was able to get a really good test accuracy for each model this time around. So for our first model, we have k nearest neighbor. the binary regression classifier. So for the k nearest neighbor, I was able to get something working pretty fast. I read some documentation and looked at the data set. There was a README. It was pretty important just to be able to figure out which was actually the target and the features. But then I began to optimize my code so I could have it basically run through multiple k values for me and find the best answer, so I don't have to constantly change stuff. I did use standard scalar. It improved the accuracy of the model. So this is probably likely to due to some feature outweighing other feature. You can see that I found the optimal k value to be 5 for k and n. Crossfold was 90.61. Test was 90.27, and training was 93.91. They weren't more than 5% apart, though. So I would not say it's overfitting or underfitting at 5. But out of all 1,152, we misclassified 112, which is quite a bit. So, like I said, 1 to 4, probably overfitting. It hits a sweet spot, and then it gradually starts to underfit. And it just continues to underfit. Next, we have the logistic regression classifier. So for this model, I was basically able to carry almost everything over. I still used standard scalar. It also improved the accuracy of this model. And I found the optimal C value for this model to be 1. The K cross-fold validation accuracy was 93.19%. Test accuracy was 91.92%, and training was 93.57%. I also find that this is likely not underfitting or overfitting because the percentages are not more than 5% apart. And we actually classified or misclassified less than 100 emails. We got down to 93. This was also very quick at 2.404 seconds. Here you can see the graph for this model. I found 1 or 10 to the 0 to the best C. I would consider the first point to be overfitting. And then over here at the tail end, I would probably consider it underfitting. But at 91.92%, regression or logistic regression is the best so far. Next, we have linear support vector machines classifier. So linear SVM for short. I was able to carry quite a bit over from the other two models. I still use standard scalar, but I had quite a bit of trouble with this model converging. It suggested to increase the iterations. I even took it all the way to 50,000, but my program drastically showed down, and accuracy was actually decreasing. The warning also never went away. It would even show up in my terminal after my code was done executing. So here it's in the middle of output after the machine learning's done already. My optimal C was found to be 100, and that gave me a test accuracy of 91.57%. That would be 97 emails out of 1,152. For this model, like I said, I found 100 to be the best. On this graph, that's 10 to the square, which is all the way up here. For this specific model, I would consider basically before this to be overfitting. Begins regularizing well, hits a sweet spot, and then rapidly underfits from there. At 91.57, this fell just shy and ended up in second place. And KNN came last, with logistic regression coming in first. So let's talk about explainability and accuracy. So these are the K five-fold cross-validation accuracy results. But logistic did also have the highest test accuracy results as well. But a few things can be explained anyway. The best model, I think, in this regard is logistic regression. Linear SVM, while it has a comparable percentage, it took way longer. I had trouble getting it to converge. And then the explainability of each model makes logistic regression even a better model to me, because logistic regression is very explainable. It applies coefficients to each of the features, and it makes basically a relationship to the outcome. So it makes it easy to understand and use repeatedly. Linear SVM can be used like that, but it's a lot more complex. And then KNN actually is a black box model. It's very hard to understand why it makes decisions in some cases. Well, that is it for homework 2, Introduction to Machine Learning. Thank you. Have a good day.